Hi, let's take a look at how the graphing calculator can be used to perform some of the objectives we've discussed in this section. So I'll show you how you can find the maximum and minimum points on the calculator, graph piecewise defined functions, and also identify if a function is even or odd. So to do this, let's begin with the maximum or minimum. You're going to enter the function, graph it, and then choose from a menu whether or not you want it to do the maximum or minimum point by answering a series of questions, and then you'll have the maximum or minimum being displayed at the bottom of the screen. So let me illustrate with a problem that is in your textbook. From the homework set, it is f of x is equal to 3x squared minus 12x. So I've entered the function in the equation editor, and now I'm going to graph it. I see that this is a parabola that opens up, so this has a valley, which means that there's a minimum point on this graph. Now, to clearly view that, I need to change my window so that it goes further down in the negative y direction. So let me change that. Let's put maybe negative 15 in for the y-min, just something a little bit further down in graphs. Yep, that did it. So now I need to find out what is the ordered pair that corresponds to this bottommost point on the graph. To do that, I'm going to press second, trace, and you have to tell the calculator which one, minimum or maximum, so we want to choose minimum, which is number 3. Then it asks you for left bound. I said upper or lower, that left or right bound, either one. Left bound means some point to the left of that minimum point. So I'm going to use my right arrow key and go somewhere. I'm moving in a little bit closer to this point. It doesn't really matter exactly where you are as long as you're on the left side. So think about drawing a vertical line through that minimum point, and you want to be somewhere on the left of it. So, and then press enter. Now right bound, you want to move to the right of that minimum point and press enter. So you see that it puts marks there, and now for the guess, you want to move between the two marks that were placed on the graph and press enter. So this is telling us our minimum. When it does this 1.99999 negative 12, you can assume that really is 2 negative 12. Now remember what that tells us though about the minimum point. The minimum function value is the output value, so we would say the minimum value of this function is negative 12. It occurs when x is 2, but the minimum is negative 12. Okay? You want to do one more? Let's look at, for instance, number 40. Let me clear this one out. So if I put in negative x cubed plus 3x squared. And now we will graph. Okay? Now this particular function has a minimum and a maximum. So let me just do the maximum since we just illustrated the minimum on the last example. To find out what that maximum point is, I would press second, trace, and now choose maximum. I need to be somewhere to the left of this point, which I am with the point that's actually displayed there, so I can press enter. And now I need to move to the right of that peak and press enter. Now guess moves somewhere between those two marks and press enter. So the maximum is, here again, is a 2, 4. So that means the maximum value of this function is 4, or the relative max. It's not the absolute max because it goes on up to infinity, but in this region the relative max is 4. Okay? So let's take a look at how we can perform the next objective, which is to graph piecewise defined functions. For this particular objective, you're going to enter each separate rule into one of the equations. So if you have two pieces to your function, you're going to use two of the equations in the calculator. If you have three, you'll enter them in y1, y2, and y3, and so on. And this is the way you have to do it. It says to enter both the rule and the restriction in parentheses, and you also need to enter the rule divided by the restriction. So we would enter this as 2x plus 3 in parentheses divided by, in parentheses, x is less than 0. And then in y2 we would enter 3 minus x in parentheses divided by x is greater than or equal to 0. Now, to get the inequality symbols, you're going to need to use the test menu. So let me show you how you can do that on the calculator. So in y1, I want to enter in parentheses 2x plus 3. And then divided by, in parentheses, my variable x. Now I need to enter as less than 0. So I'm going to say second math to get that test menu. Less than is 5, 0. My second piece is in parentheses 3 minus x in parentheses divided by, in parentheses, x is greater than or equal to 0. X greater than or equal to, again I'm going to do second math, which is a test menu. Greater than or equal to is option 4, 0. And then close. And now I'm going to graph that piece, or that function. Okay? So there it shows me the two pieces of my graph, which is a complete function. Now it's interesting if you look at the table for just a moment, second graph. Notice how there's error in part of those, and that's because one piece is not defined for everything, right? The first rule, y1, is only defined for values of x being less than 0. So that's why you're going to see a y1 entry for those particular values of x that are less than 0, but an error in y2 because y2 is not defined there. y2 is only defined for values of x which are greater than or equal to 0, and so that's why you're going to see the y2 values coming into play, but the y1 has an error because again it's not defined. Okay? So just to recap what we had to do there, we had to use our test menu to get the inequality symbols that we needed to display. Okay? Now, the last objective, to determine if a function is even or odd on the calculator. This is pretty nifty what you can do here. So let's look at an illustration of that. Let's clear all of these things out. So I gave you a few options. You can enter the function, obviously, then you can look at the graph and look to see if it has symmetry about the y-axis or about the origin. You can also look at the table and see how the y values of opposite x values relate. And then you can also play around with entering different types of functions to compare to the original function. So I'll show you all of those. Let's look at, for instance, number 78 is negative x squared minus 8. And now graph. Now, just by seeing that, hopefully you could see that that is symmetric with respect to the y-axis, so this is an even function. I could also do the table by second graph, and here I need to compare how the y values of opposite x values relate. Well, notice this, that an x value of 1 has a y value of negative 9, but also negative 1 has a negative 9 output. 2 has a negative 12 output. Negative 2 has a negative 12 output. 3 and negative 3 both have negative 17. So opposite x values have the same or equal y value. So that confirms that that is even. Another thing I could do if you really want to get fancy on the calculator is you can enter, you know how we have to enter negative x in place of x. Well, you can use a function notation here and actually do in y2 enter, so to speak, an f of negative x. We would have to call it y1 because that's the way we've designated the original function. And so if you wanted to do that, you could go to vars and go over to yvars and choose function. And from that list you'll see y1. So you can choose y1. And now we're going to evaluate that at negative x. Okay? If these are the same, then we know the function is what? Even. Now I'm going to also display this differently. I'm going to make it bold. So if I go to the left of the y2 and press enter, I get another way that displays. So what I'm going to see on my calculator is if the bold graph is drawn on top of the original graph, then I know I have an even function. So if we go to the graph, you see how it was done that way. So that confirms that that is even. Okay? We can illustrate this with one more. Let's look at the square root, or let's do the cube root of t minus 1. To do the cube root, I'm going to have to do second. No, let me not do that. Let me just go to the math menu. And the cube root is number 4. Okay. So math and number 4 gives me the cube root of t minus 1, or in this case x minus 1. Okay. And graph. Now, this does not go through the origin. To be symmetric with respect to the origin, the graph actually has to go through the origin. It looks like it might be, but it's not really. So just from the graph we know that it's going to be neither even nor odd because it's definitely not symmetric with respect to the y-axis. But you can illustrate this with the output values for opposite x values. Notice how for negative 1 and 1, those values are not the same or opposite, so this would be neither. Okay. Again, you can confirm with what I did before, like if I wanted to check what y1 of negative x would be. So if I go to vars, yvars, choose option 1 and 1, and put in negative x, and we can have that one display in a bold face. And graph it. Okay. So it's not going to be the same or the opposite of that original function. So therefore this is neither even nor odd. Okay. So that concludes how you can use the graphing calculator. If you have any questions, please don't hesitate to contact me. Thanks.